cosine x from both sides, I would get negative 2 cosine x equals negative 2. Right? Then I would divide both sides by negative 2, and I would get cosine x equals 1. Agreed? Now, again, a couple of ways you can get there, but if you follow algebra rules, you'll get to this spot right here, right? It has to. And then I just go cosine x equals 1, so I look up there and go, that only happens when x is equal to 0 degrees. And since it's asking for principal values, there's only one answer, and that's it. So I'm going to circle it and call it a day. Right? Feeling the good? All right, I start working on 2. Algebra first, right? So you have a couple options here. What do you want to try? Add 1 to both sides. Good choice. A lot of people would try to do something different. I'm with you. That's a great choice. Now what? Divide both sides by 2. Love it. How to get rid of that square?
Ew, really? Not a fan.
So I better simplify this because otherwise I'm not even going to recognize my answer if I get it. So how do I simplify this?
Put the square root in.
Can't have a square root on the bottom, right? So multiply top and bottom by root 2.
Why did you change it to 1 over?
Because square root of 1.
What's the square root of 1?
Oh.
What's the square root of 2?
I don't know.
That gives me root 2 over 2. So this becomes sine x is equal to plus or minus root 2 over 2. I'm pausing there. Make sure he's with us.
Oh, and that's, oh.
That's going to be up there.
That's going to be up there.
At 45.
So that's going to happen at 45 degrees. And how do I get negative root 2 over 2 in principal value land?
It's going to be in the third.
It's got to be in the 4th quadrant.
So you do 360 minus 45.
That's what makes sense, wouldn't it? 315 degrees? That's not it.
What?
Remember, for principal values, we just use a negative sign.
What?
Yeah.
Oh my, it's not the same thing though.
It is the same thing. But for principal values, we have to write it as negative 45 degrees.
So lame.
I'm sorry.
That's easier.
Should be easier if you get used to it. What? That'd be fine. Totally fine in this case. Make sense?
That's a divider
Yeah.
plus.
First thing I did is I subtracted 1. I mean, I added 1.
All right. All right.
Is that illegal?
It's totally allowed. I'm just not sure why you're doing it yet. Because I do that when I'm getting ready to factor, but I see a secant squared and a tangent, and I feel like there's no factoring going to happen anytime soon. Which means I'm looking at this thing going, I don't know if I even want to move the 1 over. Now, it's not going to hurt anything to move 1 over. I'm just not sure that's my first move.
I took the square root of secant squared x.
How do you do that?
I
I would have to square root both sides, which means that I have a big square root bar here and a big square root bar here, and that's not going to do me any favors at all. That's going to be a bad situation.
mean, I just did
Could convert
bar.
You can't just do it for this, right? You'd have to move this to the other side, and then if you did that, then you'd have secant making sense, but then you'd have 1 minus tangent x in a square root bar.
Okay, so we're starting over. I'm going to change.
I'm going to start over. I'm going to start over with you. I'm with you for starting over.
convert sine.
So if I can't use any algebra on it, and again, first step, back there, guys.
In terms of sine cosine, I'm going to change tangent into
Right.
x over
But the first step is to try to use algebra. I can't. I'm looking at this thing going, there's nothing that goes together, no adding, no factoring I can do. I'm dead in the water. Now I'm going to start going trig land. Trig land is everything to sine and cosine, right?
Yeah.
So we go 1 over cosine squared x plus sine x over cosine x minus 1 equals 0.
Yeah.
Now it's a place where I can do some algebra. Now, I have lots of choices. I mean, if you want to move 1 over, there's lots of things I can do now. But now I'm in algebra land, and now I know what to do, sort of. What do you want to do?
Let's move the 1 over.
Let's move the 1 over. So I've got 1 over cosine squared x plus sine x over cosine x. Agreed?
Yeah.
All right.
And I want to multiply these.
You want to make a common denominator?
Well, I want to see, yeah, but I want to see if I can multiply the right side by another cosine x instead of doing the crossing.
So you want to multiply.
Or should I not?
You want to multiply both sides by cosine x. In other words, get rid of it here. Make this cosine x and make that cosine x.
Well, I just want to get a common denominator by doubling that cosine x and multiplying it by cosine x.
Okay, so do that. Do the everything's gonna be over cosine squared when you're done. Is that what you're saying?
Yeah, but I'm feeling what I'm thinking is
That's
different.
nothing wrong. Oh, maybe not. Okay, so let's try this out. So cosine x, this becomes sine x cosine x over cosine squared x equals 1 over cosine squared x.
Why does it need to be over? Why can't it just be cosine?
Because I'm basically so it'd be cosine, sorry, it's cosine squared x over cosine squared x. Right, because that's what 1 would be.
Why
Come
would
on.
it just be cosine x if I'm multiplying 1 times cosine x?
If I'm doing that, then I have to do it to this one too. That's cosine cubed. I don't want to do that. Whatever I do, I gotta do everything. So what I'm doing is top and bottom the same thing.
Yeah.
When I'm doing top and bottom the same thing, if I want a common denominator, I gotta make that cosine squared.
Wait.
Yes, ma'am.
This is definitely just a math question, but
All right.
I thought you only had to do the same thing with top and bottom if you're only doing it to that little phrase.
Right. That's what we're doing.
Okay.
Because we did nothing to this one.
You could also just multiply everything by cosine 2x, right? On the
If-
step above.
If I did cosine, what do you mean?
Squared x. Cosine squared x.
If I did that, then this would become cosine squared. This would become sine over. This would become sine cosine. This would become 1, which is fine. You can do that, and we're about to do that, I think, because that's why we have a common denominator, right?
Okay.
I think what we're gonna do is just drop the
Same
bottom
thing.
now.
Yeah.
That's why we did this.
Same.
What? Yes, ma'am.
Why is that? Why is that?
Why is what? Because we wanted a common denominator. We decided cosine squared was our best option, right? So I had to multiply top and bottom by cosine x to make that happen. And then I had to multiply this by cosine squared over cosine squared to make cosine squared at the bottom. Because we changed everything in common denominator, right? Because once I get rid of the common denominator, what can I do now?
Throw it all out.
If everything's the same on the bottom, then the tops have to be equal to each other, right? So I can drop this whole bottom and I get 1 plus sine x cosine x equals cosine squared x. Agreed?
Well, since when can you do that?
For a long time.
Just multiply
If you've got 3 over 7 equals 2x over 7, you know the 7s are the same, right? So the tops have to equal to each other, right? So since you set the bottoms equal to each other, let's assume that's why you did that. Because otherwise, things we could have done, and that was not. Does that make sense? Or I can multiply both sides by cosine squared, which cancels it out at the bottom of all these. This problem's a long ways from done still.
Yeah.
Okay, so now I got squareds, everything inside of cosine. I need to make myself get ready to factor this thing, right? Means I got to set it equal to 0, right?
Yeah, minus cosine squared x.
So 1 minus cosine squared x plus sine x cosine x equals 0, right? Now here's a problem. You ever got a way to factor that?
Wait, what did you just do?
Yeah.
I said equals 0. You got a way to factor this.
Oh, it's 0. 1 minus cosine squared x is sine squared x.
Okay, you saw that. I need everybody else to see that. So give me a moment. I'm going to try to get everybody else there.
Oh, I
Yes,
got it.
ma'am.
No, I don't know the question.
Okay, so I take a look at this problem and I go, how do I do this problem? I'm staring at it, I start to cry inside because there's no way to factor this. And I'm out of options, right? Sine squared plus cosine squared. So I've got cosine squared sine x. There's nothing I can do. I'm stuck. When you're stuck and desperate, there's a couple things you can do. One of them, the one that would work but would be the long way to do this, would be to go, hey, what is sine squared plus cosine squared, right?
Ew.
I could blow it up to sine squared plus cosine squared, but cosine squared will cancel out. And that would give me sine squared plus sine x cosine x. That's not the way I'm going to do it in a moment, but that's one thing you could do, and it would work.
Oh, I feel.
Option 2, 1 minus cosine squared is what?
Sorry.
Sine squared.
What? Hold on.
But that's the same thing.
Oh, is it an identity?
Right, 1 minus cosine squared is sine squared.
Chilling.
Now, can I factor this one?
Yes.
Yeah, I can take a sine x out of the front and back, right?
Yes.
So I got sine x times sine x plus cosine x. That's terrible writing. I apologize. Equals 0.
So you know sine x, when is sine x equals 0?
So I find, I'm going really fast now. Let me slow down. We here?
Equals 0.
All good? Okay. Sine x equals 0. I got sine x plus cosine x equals 0. Sine x equals 0 when, where?
It's 0.
What's my answer is going to be in terms of? 0 to 360, so it's going to happen at 0 degrees. At 360, totally agree with that. What else? One in the middle, guys. 180 degrees, right? Because it goes like this. It's got to be in the middle as well, right?
Yep.
So that's just that part. What about this part here? This is the part that it's going to... I re-reminded the calculus students they need to know how to do this just a little while ago.
Oh.
How am I going to solve this?
Sine.
Where does sine give me a negative cosine? Now, that's one way to do it. I'm going to show you a trick for us people that don't like doing things like that.
You just have to do it.
When I have a sine plus cosine, I can write this as sine x equals negative cosine x. With me so far? Totally loud? So, I'm going to divide both sides by cosine x.
Tangent.
Equals negative.
So I get tangent x equals negative 1. That's something I'm on the chart and doing like I know how to do, right? So if you've got a sine plus a cosine equals 0, move the cosine over, divide by the cosine, and you end up with tangent, right? That's a trick. Saves you a lot of time and effort. Or you can use the, when does sine equal negative cosine? It's just quadrants, and it's figuring it out by looking at the chart, right? So you can do it. This is a little bit saner. Okay, so where does tangent give me negative 1 between 0 and 360?
Negative 45 degrees.
Negative 45. Oh, careful between 0 and 360 though this time.
So 115.
So it would be, what quadrants? It would be this quadrant, right? Read the instructions. Mario? Let her get caught up.
Yeah, between 0 and 360.
So I have to answer between 0 and 360. I'm no longer allowed to say negative 45. That was principal values. These are the instructions on the previous one. Now I have to think about it in this term. So I know it's going to be 45 degrees. So that's 45 degrees here and here. So what are my angles?
360 minus 45.
360 minus 45, which is 315.
And 180 minus 45.
Which is 135. So my answers would be x is equal to 0, 135 degrees, 180 degrees, 315 degrees, and 360 degrees. Is 360 not allowed?
It's less than.
Less than. So no 360. Whoever told me 360 is allowed is wrong. Not allowed. I was wondering about that.
Wait.
They said
0, why 0? Oh, okay, so you just put them all.
0, we solved this one. Sin x gives us 0 at 0.
Oh, okay.
And at 180. And at 360, although we just found out 360 wasn't on our chart. We're only allowed to do between equal to 0 and greater than 0 and less than 360, but not 360. Which makes more sense because otherwise you end up with 3 answers. We usually end up with 2. Woo! That was fun.